We can plot the size distribution of these taxa for any given sample. And then, of course, well, what about the fragments? What about that? So you can actually choose to plot just the whole specimens or all of them. Interestingly, it's not as different as you might think. They can combine all their samples. So any given classroom gets one sample from one layer. And then we have multiple samples from each layer, so they can compare what they found to another classroom, or they can combine all of the samples from one layer into one horizon. So this is horizon 1, for example. And then they can get summary information and so on. If you want to look at how the fauna is changing through the whole stratigraphic section, you can put all the pie charts together. Students sometimes do this. Got them laid out across the classroom. And then they get some chances, of course, to ask and answer questions. One of the wonders of technology now is that even though we can't go to these classrooms in Chicago, for example, we can Skype in with them. So you can see vaguely my colleague Trish on the screen in the background talking to these students. And each student would come up with some data and a hypothesis, and then Trish would talk to them, or I've done this, talk to them about, well, how would you test your ideas? And what if we could, when your teacher comes back next summer, what kind of data should they collect to figure that out? So this adds a lot to the possibility, basically, of creating these partnerships that go well beyond the physical limitations of being there. So very quickly, I promise not to bore you with a lot of data, but I'm sure a few of you are interested. Well, what kind of data are you collecting? Well, so right now, after 4 years, we have so far 11,700 specimens for which we have taxonomic and size data. And so one of the plot on the right simply shows its time from left to right there. The variation in relative abundance of brachiopods on the top and bivalves on the bottom. Every year we add a few more stratigraphic levels as chosen by the teachers, depending on, say, oh, that's a weird pattern. Let's go back and pick this layer and figure out what's going on. So each arrow there, each colored arrow represents a new layer. Sometimes we just find odd patterns. So after 2 years of data collection, we found that there was this one part of the section that didn't really follow the trend of the rest of it. And that created this whole flurry of questions, both from the students and the teachers, about what's going on there. And so when the teachers came back the next summer, they went and they collected in more detail around that particular point. We see this really funny, it's not previously completely unknown that there was a size change, especially in the bivalves through the section. That would be, again, time from left to right. And so you can see, I've connected the blue dots so you can see it more clearly. But no one had ever quantified that. So this provides some basic quantification of some patterns that people had noticed but hadn't necessarily followed up on. Now this pattern is more complicated than this since this data has been collected, but it's still a size increase. And here you can see it in the size data, bivalves from the top of the section and from the bottom of the section, and you can see that long tail on the top histogram there is showing that brachiopods, the size distribution is quite a bit broader. So is the data meaningful? And the answer to that is sometimes yes, but it depends on what you're doing. So Trish was the person who did the sort of expert data collection in this case. And the first thing she did was pick out some specific samples. She didn't go back, obviously, and replicate this whole thing, which would, could be her PhD. So she picked a few representative samples for comparison. And she looked, well, how many specimens did I find, and how many specimens did the students find? And she found that she notices about twice as many specimens. So, there are and they tend to be the smaller specimens, it would appear that the students are missing. She looked at, so what this plot does is it shows expert data here and student data here, and if they fall along this line, it means they're the same, okay? So in this case, it's brachiopod abundance on both experts and students. They more or less fall along the line, although it's interesting that the students usually overrepresent them. But the less common taxa are much less clear. So the things that are represented by just, like a 1% or a few percent, that data is not very good. So it's interesting. It kind of it's not unlike the Harnack data with the brachiopods. The things that are kind of rare, students tend not to. They either see them when they're not there, or vice versa. And here's one of these patterns where. So this is one of these pie charts. This shows the relative percentage of different major taxa, students or experts and students. And notice that the students think they found more things than the expert thinks is there. We found this in the Harnack data as well. Students will tend to, when they see something that they're not quite sure of, often assign it to a category that isn't really there. And I don't know that we would have necessarily predicted that before we did these kinds of studies. Size data. You'll see that students have overestimated the average brachiopod size. This is true for other taxa as well, probably because they're overlooking smaller specimens. However, the important thing is, do you see the same patterns? And so on the left here, here's student data of clam size through time. Here's expert data, clam size through time. The patterns are basically the same. And so that's why we think this could be good enough for reconnaissance data. It may or may not be the data that you want to publish as your primary scientific data, but it certainly could be used in partnership. So finally, I want to close with this. There are lots of different ways of doing citizen science projects. The one that I just told you about, we spent a tremendous amount of time planning the measurements and exactly how we were going to do it, doing data assessment and so on. So that's sort of at one end of doing citizen science. And even given what we've done, we still feel there's a lot of uncertainty. So I want to go back to that original question. Imagine a world in which every child has an experience doing science sometime in their school years. And imagine what you might be doing that might promote that while also providing some kind of data for research projects that you wouldn't have otherwise been able to even think about. We have to remember this isn't a replacement for getting kids out into the real world. We have to think about how to take that outdoor experience and bring it into the classroom, but then integrate these science experiences with it. And so there's this whole other area sort of that I think is also interesting and worth your time and thought, is this idea of how to blend the outside with the inside, what we sometimes call virtual fieldwork. People actually do this when they go to Mars. But right now, the next step in fossil finders is thinking about how do we bring the fossil finders fieldwork experience that the teachers have into the classroom. And so that's another thing, as you're doing your fieldwork, how do you document it in a way that's not just show and tell, that can lead to actual questioning like you do when you go into the field. So thank you very much for coming today, and I'd be happy to take any questions.